First of all, welcome to all of you for joining me on this afternoon, on this weekday afternoon. So I truly appreciate the time and interest that you're taking out in spending this 1 hour with me, knowing more about the topic at hand. I surely hope that the session would be useful for you as we try to delve more into what are the possible career tracks that exist and also give some insight in terms of which is the right one for you or how can you make a right decision about it. So before we get started, a very quick intro about myself and the company I represent. So Sabha's already spoken about me. I am the co-founder at Great Learning, and I'm also the admissions director at Great Lakes Institute of Management. Through Great Learning and Great Lakes, I have been very closely involved with analytics education for the last 5 years. In fact, at Great Lakes, we were one of the first institutions to set up an analytics center of excellence about 6 to 7 years back now, when there was very little happening in analytics education in India. So we've been fortunate to have that first mover advantage, work very closely with companies, and also scale up various programs and our own corporate relationships in analytics, so that we've had a ringside view of how things have changed and how the industry has evolved and how the requirements have changed. And these are the kind of insights that I have tried to pour into this presentation so that they can be more useful for you. A quick word about Great Learning. Great Learning is one of India's leading edtech companies, which focuses on professional education in data science. So we have multiple programs in business analytics, big data, and data science. We are an online blended learning company. We focus purely on executives, working professionals, and we represent Great Lakes as our academic partner. Over the last 4 years of our existence, we have delivered over 1 million learning hours in analytics through various programs and engagements. We have some stellar faculty in analytics who are now consistently ranked amongst the top 10 in the country. We also take great pride in the fact that we deliver and, in fact, designed and conceived India's top-ranked analytics program for 3 years now. As things stand today, we have 4 programs in data science, and we train about 5,000 plus professionals annually through 6 centers that we have in leading cities in the country. So that's a quick brief about Great Learning. Let's quickly jump into the topic at hand. I'm sure all of us by now have either experienced or heard about the data revolution. Even as consumers, if not as professionals and clients, we have seen how data forms such a critical part, not just of our professional lives, but also of our personal lives. And this is a trend that has been happening almost for the last decade now. And you can see the chart that I have put out, which shows the data explosion that's happening, right? So it took about 5 years to go from 1.1 zettabytes to about 1.2 zettabytes. Just for the uninitiated, zettabytes is about 5 magnitudes higher than terabytes. So, and every magnitude is about a multiplication factor of 1024. So you can imagine the volume of data that we're talking about here. So in 2005, the entire data that existed in the world was about 0.1 zettabytes. In 2010, it went to 1.2. So, a 10x increase happened in 5 years, but then you can see the rapid change that's happened, right? From 2012 to 2015, you almost done a 3x increase in 3 years, right? And again, from 2015 to 22, that's almost going to be like a 5x increase. So that is the kind of data explosion that's happening in the world around us. And what we see with businesses all around is that in the last 15 years, companies have moved away from data as a cost. Previously, if you look at the 90s or even the early 2000s, you would see that companies were, setting up large data centers, but at all those points, data was seen as a cost, as a liability. And today, for every single company that exists, big or small, agnostic of the industry that it operates in, data is an asset. So that is a huge shift that has happened. In today's time, data drives decisions. We have experienced these as customers. We see this every day as business leaders. Every decision that is taken has to be on the basis of data, on the basis of what data tells us, right? And as customers, you experience it in all the services you use, whether it is an e-commerce, website or application that you use, or your mobile company that you are a customer of, or any kind of other transaction. Banking, credit cards are huge consumers of data, right? So in any of these spaces, you would have seen that the kind of offering that you are provided is always on the basis of data that you have consumed and your trends or your behavior or your persona that they've built, which is all data related. What this data explosion has also meant is that the need for technology infrastructure to cope up with this level of data implosion and analytical capabilities has immensely increased in the last 5 years, right? So in fact, and that's what the title of the slide also says, that the data explosion that is happening around us is actually outpacing the technology infrastructure that we have. And that is where the whole field of big data comes in, because big data, of course, refers to data in large volumes with large vagaries. And the kind of tech infrastructure, the kind of tech stack that you need to have to manage that data, query that data, run models on that data, and finally implement analytic solutions on that data is the entire world of big data. And when it comes to analyzing this data and deriving insights is the whole world of business analytics. So both these capabilities need to increase many, many, many folds for us to grapple with the data around us and for us to make sense out of it. And it's not just about, from a consumer aspect in terms of what we are seeing data, this also has huge implications on the career side. So NASSCOM itself, in fact, there have been many, many studies in the last 12 months, and you could refer to them, but I just quoted one of them, which is from NASSCOM. And NASSCOM believes that Indian companies will need close to 2 lakh analytics and data and big data professionals by 2018. And 2018 is just about a year and a half away. And right now, if you ask me where we are, I think we are probably at about 15,000 or 20,000. So that's the kind of gap that exists in terms of what the industry needs in terms of talent and what we have right now. This is the slide that you see is something that I picked out from Indeed, the job site. And I just queried for one term, and you can see the graph that's going, right? This is showing the demand, the number of job postings that were there. You can see where it was in 2014. The job posting is for a term called data scientist, which is only one of the terms in analytics and big data. You could, of course, query for many more. But for simplicity purposes, I've just taken data scientist, and you can see where that point was at 2014 and where we stand in 2017, and how the last 12 months, the kind of growth that has been happening. What it also means for working professionals like you guys is that, the whole world of analytics, big data, and machine learning are also amongst the highest paying jobs in the country. So there have been, again, multiple studies globally, and I presented 2 telling statistics here from US and from India. And let's first go to the India one, and you can see that if you compare the average salaries in analytics versus other industries, and let's say we compare it with information technology, the tech services industry, you can see the difference already in terms of the average salary that exists, right? And this is just the beginning, because the demand for data science and big data and analytics is nowhere close to maturity, right? So whenever I get folks comparing the scenario in analytics versus information technology or IT services companies, I think a couple of points that we have to understand is that, the analytics industry grows at about 30 to 35% annually, right? And that's a conservative estimate, whereas the IT industry currently is growing about 6 to 7%, and that's like a best case estimate. So, of course, there will be a massive difference that you see in terms of what kind of career options and what kind of career growth you have across these 2 industries. If you look at the global opportunity, and that also is massive. If you look at US as a country, you'll see that some of the best paying jobs right now are in analytics consultant, right? And you can see that, and that is kind of at par with some of the highest paying jobs that exist in the US. So all the typical analytics or data related jobs are now starting to get more remuneration as compared to other conventional industries. And all of that, to be honest, is primarily a function of demand and supply. The demand in the market for such trained talent far outstrips than the supply of that trained talent, and that is why companies are ready to pay that premium. And hence, now is probably the best time for anyone to step into this industry, because people who are getting trained and stepping into the industry now will have a fantastic career outcome for the next decade or 2 or more. So as an analogy, what is often quoted is that It is similar to the opportunity that IT professionals had when they entered, in the early 90s. So the folks who entered in the IT services companies such as Infosys or Wipro or TCS in the early 90s, went on to have very, very fulfilling careers for the next 15, 20 years. And it's only in the last 2, 3 years that the IT services industry has actually matured, and it's kind of, I won't say stagnating, but has slowed down in terms of growth. Whereas the same scenario now exists in analytics and big data, that people who are entering it now, because this is that phase where it's taking off in its growth path, and people who are entering it right now will have the same kind of opportunity and the same kind of outcomes professionally in the next 2 decades. Another aspect here, which candidates often overlook, is also the career growth that happens, and that again is a factor of the growth in the industry, right? Because analytics as an industry is probably right now one of the fastest growing industries at about 35% year on year in India. And contrast that with IT services, which is growing at about 6 to 7%, right? So you're talking about an industry that's going up about 6x. That professionals have within that industry is also immense. And this chart actually kind of indicates, the growth in salaries that, or at an average level, that professionals are making in the analytics industry. And two things are crucial here. What you can also see is the jump that people are getting between the different brackets, that 0, 3, 4 to say, once you go from 3 to the next bracket, the kind of increase that happens. And secondly is the year-on-year growth. So the red one is the current year and the black one is the previous year. And you can see, especially early on in your career, the succession or the successive growth that you're getting in remuneration is really good. Of course, as you become senior and you have more than 15, 20 years of experience, the percentage points would be lesser. But even then, when you compare it with conventional industries, it'll be far better and far higher than what you're getting there. So the question is, why is data analysis a required skill set? So we've already seen that data is now already become a critical aspect for most companies. Right? So for most companies, it is not just about storing data, but it's also about working on that large amounts of data and deriving insights from it. And as our roles evolve, as the job descriptions and KRAs for various roles change, what we are seeing in the industry is that almost most of the consequential roles will have some amount of data-driven decision making in it. Irrespective of whether you're at a CXO position or whether you're at an analyst position. Increasingly, to do your job better and to grow in your career, data-driven decision making is an absolutely essential skill set that companies have started to expect. And this was resonated in the recent Gartner study, where they said that by 2020, every knowledge professional, and knowledge professional is the skilled working class that is there. So every knowledge professional has to be a data scientist. Of course, the amount of data science that you use or the models you build or deploy will vary greatly with the company, the role, and the maturity of adoption of analytics. But putting all of that aside, it is hard to foresee a future for a professional where they are not data driven. And hence, data analysis and data-driven decision making are essential skill sets for all professionals going forward. If I kind of circle back to the current scenario that we see in IT companies, and I'm sure you all have experienced it or heard about it in great detail, is there is a massive churn or a massive uncertainty that exists in the IT services companies today, and a lot of it has been written in the media as well. And the reason for that is what we call internally as a transition from scale to skill. Traditionally, IT companies, the whole business model was built around scale, that how many full-time equivalents can I assign to a given project and for how many days. Now, because the businesses that they're serving itself, they've changed. And there's so much of automation that's coming in, there's so much of efficiency and data driven approaches that coming in, that the whole full-time equivalent business model doesn't work anymore. No client today wants to bill a project or cost a project on the basis of number of people who are working on it, right? It is all about the competence of the team that's working on it. So hence it has moved, the whole pricing model itself has moved from scale, that is number of people working on a project, to skill, which is how competent are the people working on this given project, right? And that is the direction that the companies have to chart, which is why right from Infosys to Cognizant to TCS to Wipro to Accenture, IBM, anybody you name it, they all are making a major push in terms of going digital in their businesses, and digital is a function of being data driven. And for professionals working in these industries, that what this means is that is the future, right? So the future belongs to people who are going to be competent in skill sets that are in high demand, right? And analytics, big data, and data science are definitely high demand skill sets that exist. So for IT professionals who are looking to transition, I think these areas provide a very good ancillary career path, because there is a fair amount of technology involved in all of them. And since people coming from a tech background have that background, they have to learn new skills nevertheless. But it is still easier to think of a transition from IT to analytics or big data than, let us say, from IT to marketing or IT to operations and so on. But that doesn't mean that analytics as an opportunity exists only for IT professionals. Today analytics is used across all industries, from a Ford, that is manufacturing cars, having its global analytics center in Chennai in India, to banks that are using analytics heavily, to e-commerce companies, which the entire recommendation systems or marketing or CRM is completely based on analytics, to telecom companies. Companies such as Airtel have huge analytics teams, or manufacturing and energy companies. So the more I think about it, the more companies that you heard or you interacted with as customers or clients have either already have invested in analytics or are investing in analytics as the backbone of their business operations. And we see that, even in our own candidate mix, our own candidate profiles who do our programs, and we see that there's always a blend between people from IT sector to banking to analytics to consulting to manufacturing and more. Healthcare, in fact, I've not mentioned healthcare here, but healthcare is a major sector that uses analytics, right? So analytics today, point being that analytics cuts across sectors. It is not specific to an industry like IT or a role such as technology. It cuts across industries, across sectors, and provided you can learn this well and you can you can kind of prove out your competence or demonstrate your skill sets, irrespective of the industry that you are in, you will have opportunities to grow and build a career. So talking about careers in data science, which is what the topic was about. There are broadly 4 different career tracks, that exist in data science. So data science itself is a large and fuzzy term, which is an intersection of analytics, technology, big data technology, and computational technology and mathematics/statistics. But broadly, the way companies define data science is the whole field or domain of converting data to business insights. So within data science tracks or career tracks, there are 4 broad tracks that we see. One is business intelligence and reporting, which is all about working with historical data and providing dashboards and visualization and reporting it. The other is on big data, which is working with large volumes of data and building a technical architecture to first of all manage this data, that is ingest it, clean it, model it, and then to implement analytical solutions on those large volumes of data. The third is machine learning. Machine learning is a more specialized field as of now, which is highly computational and highly algorithm driven. And it is nascent, but it is something that has massive potential and that will also grow. And the fourth is analytics, which is all about converting data to decisions, or you make or inferring decisions or insights from data, right? So there, essentially what happens is that people working in the analytics part of companies are actually working on, or they're using the data layer that is there and trying to build models and force fit this data into these models and try to improve accuracy and thereby apply business context and derive insights. So broadly, at a superficial level, if you look at it, these are the four broad career tracks that exist. BI and reporting, business intelligence reporting, something that has been around for a while. It's been around for about 2 decades, and it's a stable track where there is growth, but it has been at that stage for the past many years. Big data is analytics and big data are both extremely high growth opportunities where a lot of industry is moving to, a lot of jobs are moving to, a lot of high paying jobs are moving to, and these are where most professionals are trying to upskill themselves. Machine learning is a nascent field right now, but it has a potential for the future. And machine learning, even as it comes up, it will still be very, very computational, which means it's primarily computer science driven with a lot of algorithms. And if you are extremely good at computer science and computational methods, then machine learning is a track that you can look at. For the sake of this discussion, I would be taking up analytics and big data as the two promising fields, because clearly these are the two biggest career tracks that exist. And over the next few slides, what I'll try and do is dissect each of them, try and understand, what kind of a career track should you pursue? What does each of these career tracks mean? And, what is the best way to go about it? So let's take a closer look at business analytics versus big data. So on the left hand side of your screen, you see business analytics, and on the right hand of your screen, you're seeing big data. I'll take them point by point. I'll try and help you understand at a broad level, what does business analytics mean and what does big data mean? What kind of skill sets do people need to have? What kind of roles exist? And what do people really do in these roles, right? So let's begin with the comparison, right? So business analytics, as I mentioned, is about deriving business insights from data, right? So here, your primary skill is, working with data to infer decisions, to infer business decisions that are applicable or that can be executed, right? Whereas in big data, it is about implementing analytics algorithms on large volumes of data. So basically being able to transact on large volumes of data, which means it is primarily a technology-oriented role, right, where you're building technical architecture to work with large volumes of data and implement analytical solutions on large volumes of data. Business analytics needs a mix of business understanding, domain knowledge. These are very important, because ultimately, what I have seen is that most people kind of lose sight of the fact that analytics is mostly a service, right? You're at the end of the day, you're still applying analytics to a business problem, and what is going to come out of it is also a business solution, right? So you cannot apply analytics in isolation, and separating business completely. So hence, to be good at business analytics or to build a career in business analytics, you need to have an understanding of business, of how businesses work. You need to understand the domain. What domain means is that, if you are trying to, solve a problem in pricing, or solve a problem in segmentation, or solve a problem in churn, you need to understand marketing as a domain. You need to understand that, because that is where that problem is going to be solved. Similarly, let's say if you were, working on healthcare analytics, you need to understand healthcare as a domain, right? Or financial analytics, you need to understand basic finance as a domain. So business analytics needs a mix of business understanding, domain knowledge, and strong analytical knowledge. Whereas when it comes to big data, you need to do well in big data roles and to proceed or progress in big data careers, you need a solid understanding of big data technology stack and the analytical techniques. Right? You need big data technology stack, because that is the architecture that you're going to build, or you're going to manage, or you're going to enhance, that is going to talk to and work with this large volumes of data. You need you need to understand analytical techniques, because ultimately what you're doing is you are implementing the modeled solutions on these large volumes of data. So you can't do that without understanding these algorithms and these techniques. So hence, Big data career track needs you to understand or needs you to have a good understanding of both these areas. The typical skill sets that companies look at for business analytics includes data mining, predictive modeling, machine learning. In terms of tools, it's R, SAS, Tableau. Visualization is a key skill set, and of course, domain applications. How well have you solved or how much have you solved problems that exist in the domain. When it comes to big data, the kind of skill sets that people look for are primarily the big data technology stack, which is Hadoop, Pig, Hive, Spark, Python, R, right? So how well versed are you with these tools and technologies? How much have you worked with them? What kind of data sets have you, large volumes of data have you worked on? How many solutions have you modeled, and so on? Beyond that, machine learning and analytical techniques are also needed. When we come to roles, what is important to understand is that career opportunity exists on both these sides. So it is not as if one has more opportunity than the other. Typically, technology companies will have a lot of opportunities in big data and also opportunities in business analytics. Business analytics, as I said, is not just restricted to tech companies. Those roles exist across the board. So if you look from a career, opportunity perspective, both of them are replete with opportunities. And you can look at the kind of roles that people have moved to. And I've taken these examples from our own programs. What are the kind of roles that our alumni have moved to by doing these programs. So depending upon your experience in business analytics, you may start off as a business analyst or a senior business analyst or a data analyst. And then you may move into more functional or managerial roles, such as an analytics manager or a consultant or a data scientist. Data scientist, again, catching a lot of traction right now, or even leadership roles such as CXOs and so on. In big data, it basically you are primarily a part of the engineering team. So you begin off by being a big data engineer or a data engineer or a senior software engineer or a big data technology specialist. Then as you grow, you become a technical architect or a data architect. And we also had our alumni transition to senior roles such as VP technologies. So I hope this kind of gives you an understanding of the distinction between the two in terms of what does each area mean, what kind of a prerequisite do you need to have in terms of understanding, or what should your inclination be, what kind of skill sets do you want to build, if you're going down either of these tracks, and finally, what kind of roles can you aspire for. So the question is, which is the right career track for you? And I think that completely depends upon your background and what is it that you really want to do, right? Because a career doesn't span a few years, a career spans a few decades. So you need to be sure in terms of what is your interest, right? What do you want to stay in the technology track, right? Or do you want to go into the functional track? Or what are your skill sets and strengths? And on the basis of that is what you can make this decision. So when you look at business analytics, business analytics primarily is a good fit for people who aspire to be in managerial roles in analytics or techno-functional roles in analytics. Techno-functional roles are roles such as business analysts and so on, where there is some amount of technology and tools that you need to know, especially R or SAS or Tableau. But at the same time, you need to have a core competence in analytics as well. The thing about business analytics is that these opportunities exist across industries and companies, so you won't be tied down to one industry. And you need to have, if you want to do well in this field, you need to have an interest in the business side of analytics. You have to be extremely strong on inference and analytical capabilities. When it comes to big data, this is primarily suited for professionals from a technology background. So it is hard to build a career in big data engineering if you're not from a tech background. So I think that is an important prerequisite. Secondly, you should have a strong interest in programming. Like if you're not already very good at it, then you should skill yourself to become good at it. And again, tools such as Python, whether it is Python or whether it is R, these are not hard programming languages to master, but at the same time, one needs to have the interest and inclination to learn these things. Just like in business analytics, you need to have an interest in the business side of analytics. For big data engineering or big data analytics track, you need to be interested in the technical track within analytics companies, because that is the kind of track that you will pursue. Opportunities here largely exist in tech companies and technology roles within analytics companies. So an interesting anecdote or an interesting observation that I can share is that I'm sure all of you or most of you would have come across these, big numbers from companies such as Infosys or Cognizant or TCS, where they're talking about laying off certain people or certain thousands of people. What people don't completely realize is that parallelly, they're also recruiting. And if you look at their recruitments, most of the recruitments are actually happening on the analytics and big data track. Right? There are massive number of opportunities that exist within, within a Cognizant or an IBM or an Accenture or an Infosys, where they are looking to build their big data technology teams. Right? So it is a question of how well poised are you, or how well positioned are you to make that transition by upskilling yourself to these opportunities where the companies are looking to hire. So the same companies that are firing people are also the same companies that are hiring people in large numbers. It's just that they're hiring for a different skill set. So now that, over the last two slides, the focus was in understanding these two different areas, and thereby, mentally you can make a distinction of what these different areas and career tracks are, and probably have a slightly better understanding of which is the right track for you. The question is, how do you go about getting into this track, right? And I think the first thing that you need to understand is that you have to learn, right? Without learning, nothing is going to change, right? You're going to continue in the same status quo. Getting into either business analytics or big data means learning new skills. And learning new skills is a hard thing. That's the first thing I try and tell all the candidates who come to me or come to any of our admissions touch points across programs, is that don't come in with the expectation that learning these things, whether it is big data stack or analytics or machine learning, is going to be easy. These are hard things to learn, and because they're hard things to learn is why companies put such a premium on those people who get to learn it and do well, right? So if you want to be in that category where you want to be fast tracking your career and you want to be having a fantastic career growth, then you have to learn these hard skills, right? And learning a hard skill needs time, needs dedication, and needs a lot of effort, right? So the distinction that you need to make across these is that you should try to learn skills and not tools, right? So if I may take you back to the previous slide, if you look at this, right? If you look at the skill sets, whether it is in business analytics or whether it is in big data, you'll see that the skill sets are a mix of hard skills as well as expertise on tools. So in business analytics, the tools I've mentioned are R, SAS, and Tableau. In big data, the ones I've mentioned is the Hadoop stack and Tableau and Python and Spark and so on. Whereas the skill sets are machine learning, analytical techniques, visualization, domain applications, business context, and so on. So the important part is to learn these skills, because tools will change, right? And if you kind of go only behind the tool certification programs, then the problem is that you will have to keep doing this every so often. And secondly, you will never get that premium in the market, because the premium in the market, and when I say premium, what I mean is that the better jobs and the higher paying jobs and the faster growing jobs are all on people who have tools and skill sets, not tools alone, right? So hence it is important to learn skill sets or imbibe skill sets. And when it comes to adding a new skill, it takes time and it takes a lot of effort, right? So there is no alternative to upskilling. You have to gain these skill sets, and you need to be in a position where you dedicate the right amount of time and pick the right kind of program that will help you gain these skill sets. The other, cautionary word that I have is what I also see in some candidates is that they believe that, okay, if I do this program, then things will just happen by itself. That also never happens, unfortunately, right? Things will never happen by themselves just because you do a course or you do a program, irrespective of where you do it from. What is important is that you not only learn these things, but you also demonstrate how well you have learned it, right? So some of the best performing candidates in our own programs across the past 4 to 5 years who've gone on to, have fantastic career outcomes and opportunities, have been extremely active in participating in hackathons, participating in Kaggle competitions. Some of them have won various data science competitions and hackathons that are hosted by companies and other forums in India. So those are the kind of things that you have to be active on, so that you get to improve, so that you're making a conscious effort to improve every given day. The other thing that you should do is also, pick a program or a course that helps you do a lot of projects, because these projects will essentially build your body of work, what we call as body of work, or like understand it like a portfolio, right? So if you're a programmer, what GitHub is to you, where you can put in various snippets of code and show the world that what you've done. You're also trying to build something similar in analytics, where you can show the world that, okay, listen, these are the kind of problems that I've worked on in analytics. So this is the kind of exposure that I have. This is the kind of hands-on application that I have. So hence you have to pick a program that enables you to do a lot of that. And finally, always pick a program on the basis of curriculum, faculty, and learning outcomes in that priority. Ultimately, your curriculum has to be world-class. It has to resonate with what the industry wants. You're going to finally learn from faculty. So faculty have to be, really stellar. And you need to be comfortable with the learning experience or the learning outcomes that people are getting in that program. The two broad options for people to learn data science today exist between online and blended. So blended, I'm referring to blended as a weekend classroom plus online. So there's some amount of classroom interaction as well. And online is, of course, fully online. And often, I see candidates struggling with what choice to make. And I think there are pros and cons to both. So it completely depends upon what you are most comfortable with and how well you understand your own learning behavior. The blended program, because it has a classroom component, it facilitates in-person interaction and peer networking, which are both extremely important. Getting to meet the faculty or getting to meet the industry guests who are teaching you is of immense value. And similarly, learning in a small group with other professionals and building a relationship with them also adds a lot of value and opens new doors for you, as we see in our programs. Online learning can work if you are highly self-motivated, because the problem in online learning is that there is a very, very high dropout rate. And the reason for that is because people don't complete the programs. They get started, but they never end up completing it. And that is because you're learning all by yourself. And if you actually look at it, that is never the way we have learned through our school or college or post-graduation or whatever. You've always been learning in small groups of either friends or classrooms or batchmates, right? And that is the way, our mind is accustomed or conditioned to learn. So you're kind of breaking that behavior and trying to learn all by yourself. So it's possible people do well there also, but you have to be a very, very, highly self-motivated learner. The other aspect is that learning from content alone is never going to happen, right? So understand that education or learning a new skill set is a hard thing. It is a high, you need to have a high touch engagement. And if people could just learn by watching videos or by just reading content, then internet has so much high quality free content available, and everybody should be learning and becoming a data scientist. But because it is not possible, because that is a tough thing to do, an extremely tough thing to do, it is also a very, very rare occurrence, right? So don't kind of mislead yourself into believing that if you have a series of videos or if you have a series of content that you can read or watch, you will be able to learn a skill set. That rarely ever happens. Right. So if I may come to our own programs, in these two tracks, in business analytics and big data, we have two different programs. Both are 12-month weekend classroom and online programs, so both are equivalent to master's programs or postgraduate programs, as we call it. Both are offered by Great Lakes and IIT Chicago, so there's again a top Indian brand as well as an international brand, so it gets a global certification. The business analytics program is about 4 years old, and that has been ranked #1 analytics program in India for the last 3 years now. Big data program is something we started last year, and it has already garnered a lot of industry endorsements and is often reviewed as India's most exhaustive big data program that exists. In both programs, there's a lot of industry involvement. So, 40 to 50% of the program is taught by industry professionals, because ultimately we want people to go out into the industry, and what they're learning has to be applicable. The focus in the business analytics program is around business domains, machine learning, predictive modeling, data mining, visualization. And in terms of tools, what you learn is R, SAS, and Tableau. When it comes to the big data analytics program, the focus is on the big data tech stack, the big data technology stack, applications of it, building large scale architecture / big data infrastructure for projects, machine learning, visualization, and a complete stack of big data technologies. In the business analytics program, the last 3 months, it's a 12-month program, so the last 3 months is completely dedicated to business domain applications, where you get to do case studies and mini projects across various domains, such as financial analytics, marketing analytics, supply chain analytics, and so on. In the big data program, you also learn through a lot of mini projects where you're actually implementing large-scale big data analytics problems on data sets. So this is again not theoretical but completely application driven. And you can see in both the programs, the objective of doing this is so that you get to showcase a lot more, rather than just putting a given postgraduate certification on your program. You are also now showcasing about the work that you have done, the kind of projects that you worked on, so that companies start to look at you as someone who has exposure in analytics or in implementing analytics or big data solutions. Over the last 4 years, through our various programs in data science, we've had several thousands of professionals going through our programs. So far, we've had about 3,000 plus professionals who graduated from our programs in analytics and data science across all kinds of formats, whether it is classroom, online, or corporate engagement. We've been fortunate to have a very, very high success rate of alumni transitioning to roles in companies in analytics. So in the report that we audit and release every year, so as per 2017 report, what we see is that 66% of our alumni have transitioned to roles in companies in analytics within 12 months of completion from the program. And these transitions happen from multiple areas. So transition from IT to analytics is a very, very common thread that we see, since half the class comes from IT. We also see transition from non-technology roles, such as business development, finance, operations, to analytics teams in their own organizations or other organizations. And if you look at these reports and kind of see the companies where the alumni are working, these are all blue chip companies, the best of names that exist, that are doing fantastic work in analytics. And again, they're across the board, right? From IT, whether it is Accenture or CTS or IBM, to banking, whether it is RBS or Bank of America, or product companies such as Adobe or Amazon, or analytics consulting companies such as Fractal, Mu Sigma, and Deloitte, and so on. Over the years now, because there are also senior professionals who participate in the program, we've seen our alumni in analytics leadership positions in various companies. Our analytics alumni have also been winners of several data science challenges, the recent being the Capgemini India Data Science Challenge, which was won by one of our alumnus from the programs. So there's a lot more information on these, and if these interest you, you can write into the email ID info@breaklearning.in, and we'll be more than happy to share the alumni success report with you. Which the point there being that it should give you the confidence that you're not the first person to chart this path. There have been several others who've done it successfully, so there's no reason to believe why you cannot do it, because most of these professionals who have done these transitions will have their backgrounds very, very similar to where you are today. What is important to learn is, how did they do it, right? What were the right things that they did? What did they learn? How did they learn? How did they present their candidature? How did they improve their candidature? So I think those are the things that you should look to learn, and that those are the kind of things that we try to encapsulate in this report. All right. So at this point, I think we can start taking questions. I can see that there are a bunch of questions that have come up. So we have about, I think, 15 minutes. So I'll start taking questions one by one, and hopefully I'll be able to take most of them. So let's get started. So I have a question from Shatapan. how automation impacts data science and analytics industry in the future? I think that's a good question. So automation is playing a very important role, as we know, in the IT services, and especially if within IT services, if you look at testing, automation is becoming extremely critical in testing. That's actually what has taken away most of the jobs as well, right? So most of the job losses that you hear have been a consequence of automation coming into manual roles or checklist-based roles such as testing. Now, how does automation play in data science? See, I think what is going to happen is that on the technology side, implementing packages or building large-scale systems or testing them out is going to get automated as things get more and more scalable. But the final aspect of when it comes to deriving insights or designing systems, large-scale systems, or designing big data architectural solutions, these things are not things that automation can take away, right? And those roles and that opportunity still continues to exist, and hence it is all the more important that you learn this as a skill set and not just as a tool. The next question I have is from Chitranjan. What is the difference between data science and data analyst? I think that I did cover, Chitranjan, in detail in one of the slides. So data science is actually an all-encompassing term. The real difference you want to understand is between a data analyst and a big data engineer. A data analyst is, sorry, is someone who works on the business side of analytics, essentially looks at data and tries and derives insights. Whereas a big data engineer is somebody who works on the technology side of analytics, who is looking to implement analytical solutions on large volumes of data, right? And data science is more of an kind of an all-encompassing field that involves all of this, right? So some companies will interchangeably use data science to refer to business analytics. Some companies may use data science to refer to as more of big data analytics. So that keeps changing, but broadly that is a distinction. So I have a question from Krishnan Raju. How ideal is it for a QA automation engineer with 10 years to get into data analytics? So you started your question by saying how ideal is it? I think it is necessary, right? Because otherwise, as we are seeing, automation and its impact on QA roles, unless and until you are extremely sure of your future, it is a dangerous place to be in right now. So that transition has to happen. And what you have to figure out is how can you make that transition happen? One thing that I have seen, and several of our students and alumni, and a lot of them have actually transitioned from testing to, to business analytics or big data, is basically picking up these skills. That is number one. And also, adding onto your QA side. So you already have a background on QA. Now, if you learn the big data engineering side or the big data technology side, you will be able to kind of immediately transition to a QA side or to a QA role on big data technologies, which itself is valuable. And from there on, you can actually progress further into, big data engineering and big data analytics. So that could be a career path that you could chart. And I think it is smart if you do that. Because as we are seeing, automation and its threat to QA is quite real. The question from Dopa Sudhir is around what are the technologies used for data scientists? So again, Sudhir, these are things that I think we covered earlier. So depending upon what side of the spectrum you are in, are you on the business analytics side or are you on the big data side? The stack of technologies that you use are very different. On the business analytics side, the stack of technologies would be around analytical languages such as R or SAS, or in some cases Python, and visualization tools such as Tableau. On the big data side, the tech stack would be mostly around the big data tech stack, which is the entire Hadoop tech stack of Hadoop and HBase and Pig and Hive and Spark, MongoDB. And for visualization, again, Tableau or any of the other visualization tools. So those are the kind of technologies you'll be using. But as I mentioned, I think by now multiple times, is that the tool stacks will keep changing, right? So don't be married to them. Today, with the Hadoop stack is used predominantly, and R is used more than SAS. But to give you an example here, when we started the program 4.5 years back, our primary tool of instruction was SAS. because SAS was being used by most of the companies. Today, our primary tool of instruction in the business analytics program is R, because R is being used most by companies. So these things keep changing, right? So if your foundations are clear, and if you have, if you build a very strong skill set on the foundation and the core area, whether it is big data or whether it is business analytics, learning tools is never the hard part. Okay. Next question that I have is from Rafat. You're referring to a graph, Rafat. The jump from black to red is for other profiles to data science profiles. I think you are probably referring to the salary increase year on year between the last 2 years in analytics professionals. So those are entirely for data science profiles. So people working in data science or analytics or big data profiles, last year's salary comparison to this year's salary comparison. That's what it indicates. Again, a question around data scientist roles. What kind of technical knowledge is expected of data scientists? And this question comes from Vivek Agrawal. So Vivek, here, if you are, because again, different companies use different nomenclature for data, understand that by looking at the KRA, the key responsibility areas, or the job description. So if that role largely falls into the big data arena, you need to be good at the big data technology stack, and to learn that itself, you should understand programming very well. So there, the minimum prerequisite is definitely R and Python. You should know these for sure. And if the role involves you to work on big data tech stack, then you need to be well conversant with Hadoop and Pig and Hive and Spark and MongoDB. The next question that I have is from Ravindra. For people with IT experience of more than 15 years, what are the immediate opportunities to make an entry into analytics career? So as I understand, Ravindra, your question is about professionals with more than 15 years of experience. How can they move to analytics? So we've had cases like those also in our audience profile. Percent of the people have more than 15 years of experience when they come to us to do any of our programs, and they also do get career transitions. The nature of career transitions for them is primarily role changes within their own organization. So by learning this program, or by learning any analytics program, what you need to kind of indicate to your own management is that you're building the skill set. And if you can start taking more, if you can start getting assigned to projects that have analytics exposure, then that is a place where most of our people start. And then that goes on to getting them more opportunities. The tough part there is that initial break, right? So once you kind of get yourself started with some project, and obviously after 15 years of experience, nobody expects you to start as a fresher, right? So that is clearly not happening. So hence, in your existing organization, if you can start getting assigned or allocated to analytics projects and start contributing there, then that actually paves the way forward. I have an interesting question from Srinivas. What is the actual meaning when companies say organizations are moving towards digital? I think that's great, because I also keep hearing this over and over, in my corporate discussions with several business leaders. And I think that is the mandate that most companies have, is to go digital. And here, digital actually means embracing future-proof technologies or future-forward technologies. Most critical of them being analytics, big data, and data science, right? So the digital future is all about data, right? And data-driven competencies and data-driven business opportunities. So when organizations say that they are moving towards digital, what they're trying to say really is that they are changing their skill set, right? So this is what I opened the webinar with, if you remember, is that the business model is changing, right? It is no longer a model of how many full-time equivalents can I put to a project, but it is a model of how competent or how well skilled or trained is my team. team, right? So that training, that competence is about data-driven competencies, and that is what going digital means. So whether it is, whether it is digital marketing or whether it is, efficiencies, or whether it is data science or business analytics, all of these things have to do with data, or cloud computing, which is again another field that they bucket under going digital, or even fintech now comes under going digital. So all of this has a lot to do with data and data-driven competencies, and that's what they mean. Kishore, you asked a question in terms of the duration of the big data program that we have. That's about 12 months. I have a question from San. How can a person with 10 to 15 experience in other industry, such as manufacturing or finance, transition to data analytics career? So again, San, I think the sure shot way of doing this is by sticking to your industry and figuring out analytics applications that are happening there and trying to open into or trying to move into those opportunities. And today, as things stand, even within India and even more so abroad, even the most conventional of industries use analytics in a big way. So I'll give you an example. I think already gave you an example of Ford, setting up or already having its analytics facility in Chennai that serves its global operations. But Ford is not an exception by any means. You look at any automobile manufacturer, there's a lot of data that they're capturing, a lot of analytics that they're using. Beyond automobiles, even conventional companies such as a Pepsi or a Coke now have a consumer insights team, and consumer insights team is nothing but analytics, right? So these opportunities exist across the board, across industries, across companies. And at 10, 15 years, because you may be having a good domain expertise, all you need to do is add that analytics competence, right? And then these business analytics roles will be a good fit for you. And those are the things that you should try and break into. I have a question from Sambit. What's the difference between business intelligence and analytics? So Sambit, business intelligence is primarily looking at the past and reporting at how things have been, right? So it is more about recording historical data and presenting it. If you add a visual element to it, then that becomes visualization as well in terms of, visually representing it. But it is still about the past. It is about what has been happening, what has happened. Whereas analytics is predominantly predictive in nature, where you look at the past data and use that data to model solutions that are going to predict the future trends, right? So analytics is future forward looking, whereas business intelligence is reporting about the past. So both use the same, let's say the same data share, but the outcomes are very different. And hence there is more premium and more value and more opportunities in analytics, which is always about predicting of what is going to happen. All right, so I think that kind of brings me to almost the end. I'll take one last question that's here. There are a bunch of questions that I've not been able to answer. I'm hopeful that I will get these questions, and then either me or my team will respond to you guys over email, or we'll set up some mechanism of answering these. So I have a bunch of the questions around our big data program and around our business analytics program, and a bunch of questions around those. So what I would suggest is the best way to do there, in the interest of time, is to go to our website, greatlearning.in, and you can explore. There's all the information that you need, on the website. You can explore, you can understand, you can even contact our admissions team, and they can also help you with whatever information you need that will help you, make a decision in terms of what kind of a career track you want to pursue. But nevertheless, thank you again for spending the last 1 hour with me. I hope that this session was useful for you and that some questions have been answered. I have left my email ID here, and feel free to write into me with any queries that you have. I'll be more than glad to respond to those. Thank you once again, and have a fantastic day ahead, and all the best for your career.